Hello again, and welcome to episode 4 of the snackable HPC Notes video series. I think episode 3 grew well beyond snackable to a full meal, so I'm going to try and keep this one shorter. A recent conversation with some customers and some colleagues reminded me of the issues around comparing benchmark results. On the face of it, comparing benchmark results to see which system is faster or better sounds simple. You run your application code or your benchmark code on system A, you run it against on system B, and the system with the fastest time is the winner. How hard can it be? Well, of course, it's not as straightforward as you might hope. There is the question of what is a fair comparison. So, for example, if system A and system B are using very different technologies, then how do you have a decision as to what is the correct number of cores or memory configurations or software versions or whatever you use between the two systems to get a fair comparison? There's also the question of what you measure. So do you measure the time to completion for a full application run? Or do you measure the timings of the most important kernels? Do you measure time, or do you measure performance per energy consumption or performance per dollar, or some other metric? I'm going to come back to all of those in a future episode because those are important aspects of benchmarking. But today I wanted to talk about another aspect that makes comparing benchmark runs or benchmarking more complicated than it first appears. If you run the benchmark on system A and then you run it again on system A, you will likely get slightly different runtimes. Mainly due to the complexity of modern computing hardware, all the different bits of hardware and software and how they interact and their individual behaviors and so on. If you run the benchmark many times, you'll get a spread of performance results, a distribution. Likewise for system B, you will get a distribution of performance results. Except, of course, the distribution for system A is probably or likely different than the distribution for system A. And especially if they're using different technologies, it may have quite a different shape of distribution as well. So comparing the benchmark results becomes a case of comparing not two individual numbers, but comparing two distributions of results. So what do you use as the headline comparison between the distributions? Is it the mean performance observed, or is it the median or the modal performance? There's arguments for and against each of these. The same for quoting the minimum observed performance or the maximum observed performance. And of course, even within that, the minimum observed performance might not be the true minimum. You might not have done enough data points to capture that. And likewise on the maximum side. It's not necessarily proper to quote a mean and a standard deviation. It's exceedingly unlikely that the performance will be a true normal distribution. Why not? Because there are clear bounds on the lower side, so the shorter timing or the higher performance side. Because some things can't take less than 0 time to happen, and things like the speed of light limit signal transfer and so on. So there's some clear limits on the lower end, and there's not those limits on the upper end where slow results can stretch well beyond the mean or the typical run times. It's one of the common things that are proposed to compare these distributions would be to compare the 90th percentiles. So the performance result that captures 90% of all runs. So 90% of all runs will be less than this performance time, for example, or faster than this performance time. But that doesn't capture the full story. It doesn't even necessarily capture the useful story. So, for example, assume we can say that 90% of runs on system A will take less than 45 seconds, compared to 55 seconds for system B. That doesn't tell us how bad the remaining 10% will be, and that could be significant. So if we go to the next step and we look at the 99th percentile, then for system B, the 99th percentile could be 57 seconds, whereas for system A, it might be 300 seconds. So whereas system A has a 90th percentile that's faster, 45 seconds, once you get out to those last 10% results, they could be stretching out into the hundreds of seconds. Whereas system B, on the face of it, looks slower at 55 seconds, but there's a very, very low probability of getting a result that stretches beyond 57 seconds. So it looks on the face of it a tighter distribution of results. And the question, of course, is which of these do you care about more, or which do your users or your customers care about more? Is it the best result the system can deliver? Is it the most probable performance result that a specific customer running a specific application is going to come across? Is it the best situation across a large number of runs? Either a user running a large number of runs, or you're running a HPC facility, looking at the performance across all of the users. Or is it the worst case performance, or the likely worst case performance that an individual job by an individual user or customer is going to encounter? And there's no right or wrong to this. It's just about knowing what you're comparing and why. Perhaps the answer also depends upon why you're doing the benchmarking. Is it to showcase one of system A or B? So, for example, for marketing purposes or sales purposes? Is it as a part of measuring system A and system B within a procurement process? You're trying to help give information as to which one you should buy. Or are you doing the benchmarking to diagnose application performance or diagnose system performance behavior, perhaps to tune the application for the future, or to scale it better, or perhaps to try and understand why the performance is not as expected? So I could go on, and indeed I have delivered courses where I explore these topics in a lot more detail and the merits of different approaches and so on. But I did say I was going to try and keep this video short, so I'm going to stop here. The benchmarking is more complicated than it appears, and that's really the snackable takeaway, if you like. That comparing benchmark results is not as easy as it may seem. So as I said, in a future episode, I'll come back to looking at some of the other aspects of that. For now, feel free to add any of your views or experiences in the comments. But that's all for episode 4. Keep an eye out for the next episode, and as always, do feel free to make suggestions for topics for future episodes. Thanks all.